Okay, let me start with an example. The first example has one variable, an equation with one variable. The equation is 9 over 1 plus x plus 9 over 1 plus x squared plus 109 over 1 plus x cubed equal 110. Let's solve this equation. You might have seen this equation in the field of finance or asset pricing, but you don't have to know about finance. Let's just solve this equation today, okay? Our approach is to define a function. Let's call this function f. And we define a function by collecting all the terms to the left-hand side or in the right-hand side. Okay, for example, if I move this 110 to the left-hand side, I can define a function. So this is my f. Okay, f is, we want to solve this equation, and we define a function f of x, and f of x is this left-hand side minus right-hand side. Okay, now if we can find a value for x that makes the value of this f of x 0, that x is a solution to the original equation. That's the idea. If we can find a value for x that makes this whole thing f 0, the x is, that x should be a solution to the original equation. That's the idea. Okay, so let's define function f first. Now I explain about functions, how to define a function, how to use a function in some other videos. So if you're not confident about functions, please watch it. Today, just for a short recap, a function, the function to define a function was a function. Yes, so f is a function of x open braces, and here I define some other variable. Let's use y, and y is, this is how to calculate this y, and in the end I say return y. This is how to define a function. You have to use this command function, but this f and x and y can be anything. You can use any name. It's f and x and y can be anything. Okay, now let me run this part. Okay, now f appears on the right hand side, so f has been defined. Let me use f. Let me try using f. F of 0.05, for example, is 0.89. How about f of 0.06? That's negative 1.98. I want to make this value 0. Okay. How about f of 0.053? Now it's very close to 0, 0.019. In this way, we want to find a value for x that makes f 0. Okay, and we are going to do it using a package called, a solver package called nonlinear equation solving. Now, the first time you use this package, you have to download and install it. So go to console command and type install, here you go, this first one, install.packages, not the second one, the first one, install.packages, and with double quotations you specify this package name, nonlinear equation solving, nleqslv. Okay, I have already installed it, so I don't enter it, but please enter it, and R Studio will download and install this package for you. You have to do it only once. You have to do it only once. Once you do it, the package will remain in your R Studio forever. So you have to do it only once. I have already done it, so I don't do it. Now, installation should be done only once, but every time you open R Studio, you start R Studio, you have to call this library. So, using library command, library nonlinear equation solving. You call this package and then you can use it. Now, this thing, you don't have to do it every time you use solver, but once you close your RStudio and on the next day you start RStudio again, you have to call the library again. Okay? The syntax to solve an equation is this. nleqslv, and this function should have two components. First, you should give the initial value of search. Okay, initial value of search, and the name of the function you want to make 0. Okay, this time we defined this function f. So I want to make the value of f 0. I want to find x that makes the value of f 0, and I want to search starting at x equal 0.05. Let me run this line. Okay. The result is composed of a bunch of things. The first component is $x. This first component is the solution. The solution is 0.053. Okay? When x is 0.0530 ... the value of f is 0. The value of f is 9.119 e. This e minus 10 means 10 to the power negative 10th. So it is 0.00000000911. So it's very, very close to 0. It's regarded as 0 numerically. So this x is a solution. This fourth component message is also important. It sets function criteria near 0. This indicates that solver could successfully find a solution. Solver doesn't always find a solution, but this time it was a success. Now I can save this solver result in a variable. For example, I can define a variable named myResult and save this bunch of things in this variable. Let me run this file. Okay, now my result, the variable my result has been created, and my result is this, the set of results. Okay, if I want to extract only this solution part, I can use this dollar symbol. So my result dollar symbol x would give me the solution part 0.053. If I want to extract this message part, I say my result dollar symbol message, and it shows this message. Okay, this is how you extract a specific component from this list. Okay, dollar symbol. Okay, let's move on to the second example. The second example is a system of equations. Let's consider a two-variable case. We consider a system of equations of two variables, x1 and x2. The equation is 3 times x1 minus 5 times x2 equal negative 1. The second equation is x1 plus 6 times x2 equal 15. Okay, this is a system of equations, two equations for two variables x1 and x2, so we should be able to solve it. Let's solve it using nonlinear equation solving package. Okay, again we should define a function. Y equal f of x, where y has two variables and x also has two variables. it goes like this. Let's call this function myf. Okay, and this time x has two components, so let's rename each component. I call the first component of x as x1, and I call the second component of x x2. And once x1 and x2 are defined, I can calculate y1 and y2. y1 is okay, 3 times x1 minus 5 times x2. I move this right hand side to the left hand side, okay? Plus 1. And y2 is x1 plus 6 times x2. Again, I move this right hand side to the left hand side, so minus 15. Once I calculate y1 and y2, I put them together to define a vector named y, and I return y. Okay, so this is the function has been defined. Let me run this part. Okay, so my f has been defined. Now this function needs a vector of two components. So I cannot say my f of 1, 1. Okay, I should give a vector. So I should give vector 1, 1. Okay, then minus 1 and minus 8. So when x1 is minus 1 and x2 is minus 8, y1 is minus 1 and y2 is minus 8. Let me try. My f of 2, 2, excuse me, 2, 2. Okay, when x1 is 2 and x2 is also 2, y1 is negative 3 and y2 is negative 1. Again, we want to find x1 and x2 that makes y1, y2, 0, 0. Okay? So let's do that using solver. This time I call my result 2. The syntax is nleqslv. I should give the initial value of search. Let me give 1, 1. Yeah, this is important. This is the solver should search from somewhere, right? It's very similar to when you search for some item in your room. If you start to search somewhere close to the item is located, there is high chance you can find the item. If you start searching from a faraway place, then maybe you end up with not finding it. Okay, that's the idea. You have to specify where to start from. Okay, this time I specify 1, 1, and this time function name is myf. So let me run this part. Okay, my result 2 message function criterion near 0. This is a good news. The solver could find the solution. The solution is 3, 2. So when x is 3, 2, y is 0, 0. Consequently, the solution to this original system of equations turned out to be 3, 2. Okay? Okay, let's move on to the last example. This time we have equations with a parameter. The example is d over 1 plus x. So d is the parameter, d over 1 over x plus d over 1 plus x squared. Okay, 100 plus d over 1 plus x cubed equal 110. The first example we saw was the case where d is 9. D was 9 at that time. Okay, but this time d is a parameter, and we want to change the value of d from 9 to 10, from 10 to 11 to see how solution changes. So let's define a function. This time I call the function f2. So again, it's a function of x, and I say, okay, let me use the left hand side minus right hand side. Okay, that's the value of y. Return y. Okay, the function has been defined. Run it. f2 of 0.05 is, for example, we cannot use this function. The function now says d is not found. Yeah, there is no d. I have to specify d. So okay, let me do this. D is 9. Okay, now there is no d, but once I run this part, here you go, d appears. D is now 9. Then I can use this f2. f2 of 0.05 is 0.89. Now let's use nonlinear equation solving. nleqslv. The initial value, let's set it at 0.05, and I want to make f2, the value of f2, 0. Function criterion near 0, and 0.053 is the solution. Okay, and then if I want to change this value of d to 10, I say d is 10. Run it. You see, look at this right hand side panel. D is now 10, and then I can execute the solver again. Function criterion near 0, but this time the solution is slightly different, 0.06. This way, when an equation has a parameter, we can define a function with a parameter, and we can change the value of the parameter and solve it. In this way, we can see how the solution changes as the parameter value changes. We can save them as well. For example, let me define a variable named my solutions. Let me define it as 3 zeros. Okay, 0, 0, 0. And then d is 9 again. And the solver result I save the solver result as the first component of my solutions, and then d is changed to 10, and this time the solver solution is saved as the second component of my solutions, and d is changed to 11, and this time the solver solution is saved as the third component of my solutions. Okay, my solutions. Okay, sorry. Yeah, this nonlinear equation solving result is a list of things. So to extract the solution part, I should have put $x, $x. Okay. Yeah, here you go. This time we succeeded. So when d is 9, the solution to this equation is 0.053, and when d is 11, the solution is x equals 0.071, and so on. Okay. So again, when an equation has a parameter and you want to change the value of the parameter to see how the solution changes, make a vector, change a parameter, and solve it, and save the result, change the parameter value, and solve it again, and so on.